I'll be doing problem set 6, question 5. For A, we have to find the speed of the center of mass if the ball's angular velocity is omega. We know that the velocity of the center of mass is equal to the radius times omega. And because the ball is being held up by the rails on two sides, we have to find the radius of a rotation relative to the contact point, which I set as the term s. To find s, we can use the Pythagorean theorem, which is therefore s would be equal to the square root of r squared minus d squared over 4. Thus, the velocity of the center of a mass is equal to omega times the square root of r squared minus d squared over 4. We know that the inertia of a solid ball is equal to 2 over 5 times m times r squared, and that the law of conservation of energy states that the sum of the kinetic and potential energy of the initial position is equal to the sum of the kinetic and potential energy of the final position. Therefore, a negative change in the potential energy is equal to the change in the kinetic energy. And thus, mgh is equal to the pure rotation plus the pure translation. After simplifying the expression, we get that the velocity of the center of mass is equal to the square root of 10gh over 7. For a ball on the rails, we can use the same equation. However, for omega, we would have to change it to the velocity of a center of a mass over s squared, as because the ball is rolling on, has a contact point relative to the rails, which therefore we can find the angular momentum by rewriting the equation here, which gives us the velocity of the center of a mass divided by s. After simplifying the expression, we get that the velocity of the center of a mass of the rails is equal to this. For C, we have to find which speed of the ball is smaller between the ramp and the rail. For the ball on the rail, we know that the radius of a rotation is smaller than the one on the ramp. Therefore, the omega, or the angular momentum, is bigger. Because the angular momentum is bigger, we know that there are more rotations for the smaller radius. Therefore, the kinetic energy of the rotation is bigger. And because the kinetic energy is constant, we know that the kinetic energy for translation is smaller. Therefore, the kinetic energy for translation for the rails is smaller than the kinetic energy of the translation for the ramp, which thus leads to the velocity of the ball on the rails is smaller than the velocity of the ball on the ramp.